Welcome to another video, and today we're going to go through using the hardware debugging session and its features in detail. There are more videos about specific debugging boards coming soon, and today's video is useful once you have your hardware debugger set up. Everything you see here is the same for all hardware debuggers in Visual Micro, including custom configurations. So don't forget that there are two ways to begin your debugging session depending on what you wish to achieve. So if you want to reset the board and re-upload the code before debugging, then use the Debug Start Debugging option. And to simply attach it to where it currently is in the running code on the board, use the Debug Attach to Process option. So on to breakpoints. Just remember there are often limitations on the number of break and trace points available at the same time when using the hardware debuggers. So these can simply be added to your sketch by clicking in the left margin, either whilst you have your debugging session running or before you begin. The code will stop at the breakpoint, showing the cursor at the line of code you added the break to. Note, this is stopped before the line you are on is actually executed. You can also then use the continue button to allow the program to execute, and it will continue to the next breakpoint in your code, or the same one if it's in a loop. Once you're on a breakpoint, you may want to walk through your code in a more granular way, and you can use the step over, step into and step out of controls in Visual Studio to do this. The step over button will allow the current line of code to execute, and it will complete any function calls within that line silently. Note that loops and other standard flow constructs, ifs and switches and so forth are entered even when you press the step over button. The step into button allows you to step into the function call being executed, so you can then step through its contents with step over and step into its child functions if you need to. If you want to allow the function you've stepped into to complete and return back, then simply press the Step Out button. When analysing an issue, it can be useful to run the code to a specific point. So instead of having to manually set a breakpoint each time to continue to, you can hover over a line of code and click the small green play icon which appears. This then allows the code to run to this point and stops execution when it gets there. You can also output data to the output window and not actually stop the execution of your code. And to do this, we can change our breakpoint into a trace point. So if we right click on the breakpoint and select Actions and ensure that the Continue Code Execution box is checked. You can also add messages to the output window and include variables as needed within the curly braces. For example, a variable called LED state could be shown with some text, as shown here, with LED state : being the text and then the value of LED state being output. Then, as the program passes this trace point, it will output the text and the value to the output window as expected. So sometimes whilst debugging, you end up in code either within a library or even in the core, which is a bit too low level for where you want to be. Having the call stack window open allows you to see the calls which led to the current point you're stopped at, and you can then easily navigate your way back up the stack to code which you recognise and continue to that point. This window can be found on the Debug Windows menu, and all windows are available on this menu once you've started your debugging session. The pause functionality allows you to stop the chip executing wherever it is at the time. The call stack window is especially useful when you use this feature, as you don't really know where it's exactly going to stop on the CPU. This can be useful when the breakpoints you've set aren't being hit, for example if it's gone into an infinite loop further up in your code. You can also inspect variables live when debugging using the watch window. So we simply add the variable name into the window and the value of the variable should be shown. There are a variety of formatting options also available for this data, which can be seen in the links in the description. For example, "S" will attempt to format the item as a string. You may also find that a variable is showing as optimized out, which is a result of the compiler simplifying the code before it's actually uploaded to the board. There are a number of optimization settings available in Visual Micro, so you can tailor the optimization to not happen, for example, in your project code or your project and libraries, or even the entire project library and core. Note, the no optimization option may prevent your code from actually compiling correctly depending on which core you have. There are some scenarios as well where the compiler will still optimize a variable out, but this is often where the variable is either used or can actually be replaced, as it's only used in a single place within your code. If you enjoy this video, don't forget to hit the thumbs up button and subscribe to stay up to date with our future videos. As always, drop us any comments or future content you want to see below,